Today we are going to learn the introduction about pericyclic reactions. Before going into the introduction about pericyclic reaction, let us learn the importance of chemical reactions. The chemical reactions involving either bond formation or bond breaking with the formation of intermediate. The intermediates are classified into three types: ionic intermediates such as cation, anion, ion pair, etc., or transition state, or free radical intermediate. Further, the ionic intermediates are classified into two types, that is electrophilic, which is otherwise called as cation, nucleophilic intermediate, which is otherwise called as anion. The transition states involves in the rearrangement pericyclic reactions, whereas free radical intermediate is formed in free radical reactions. Again, the transition state formation intermediates is obtained in pericyclic reactions, in which the pericyclic reactions are classified into two based on the condition, that is thermal and photochemical. Now we are going to see the introduction about pericyclic reactions. The pericyclic reactions, as we have already seen, it involves transition state formation. So the chemical reaction mechanism involves either free radical intermediate or ionic intermediate, or the transition state formation, as we have seen earlier. The transition state formation involves it processes in single cyclic transition state, and the reactions not influenced by any solvent, reagent, structural changes, catalyst, etc. They are highly stereospecific in nature. These reactions are initiated either by heat or light. Such class of reactions are called as pericyclic reactions. They are carried out either thermally or photochemically. The chemical reaction in which starting material is converted into a single stereoisomic product is called stereospecific or regiospecific reaction. Now we can see what is the difference between a stereospecific and stereoselective reaction. A stereospecific reaction is a reaction in which the stereochemistry of the reactant completely determines the stereochemistry of the product without any other option, whereas a stereoselective reaction, the product stereoisomer is formed due to the reaction pathway being more favorable than the other available. And in stereospecific reaction, it gives specific product, whereas it will stereoselective results in multiple products. And the final differentiation is the final product depends upon the stereochemistry of the reactant, whereas in stereoselective it depends on the pathway and differences in steric effects and electronic effects. Now this pericyclic reaction, that is the pericyclic reaction means shifting of electron around the circle, are first explained by the scientists Hoffman and Woodward in 1965. As we have seen, they can take place in two conditions, that is thermal condition, which is activated by heat, or photochemical condition, which is activated by radiation energy, and both results in activated molecule. And in the activated molecule we are having different types of reaction, that is electrocyclic reactions, which leads to ring closure or ring opening, or it may lead to cycloaddition reaction, or it may lead to sigmatrophic rearrangement, or it may lead to ene reactions. And this, the next one is activated molecule, which involves electron and molecular orbital taking part in the reaction. And the molecular orbitals are classified into bonding molecular orbitals, antibonding molecular orbitals, which involves HOMO and LUMO. The process takes place between HOMO and LUMO. Here are the examples of the pericyclic reactions. Thank you.